Hello, this is Lab 2, Lines of Change. So, the purpose of this lab is to continue the work done from Lab 1 and then start treating the tapes as having the charge be uniformly distributed along the length of the tapes and simulate two of those tapes interacting on Python. Concepts here will be Coulomb's law, conservation of charge, and then the behavior of electric fields and electric charges. So, spoiler, my new results are 1.44 e negative 8 coulombs, whereas my previous results were 1.41 e to the negative 8 coulombs. It's a bit of a difference there. Assumptions. Just like before, the tape is supposed to act as a line of point charge. The charge is distributed equally along the line. And just like before, both tapes have the same charge and air resistance is negligible. So here are the data and calculations. In Lab 1, I actually wrote them down. Here, I'm just telling you what it all ended up being. The tape length was 0.208 meters. The tape mass was 0.0208 kilograms. Vertical length was 0.03 meters. Gravity is gravity, K constant 99, and electron and proton charge was 1.6 e negative 19. So as you can see, here's my computational model. I just inputted the values that I got. I got like a skeleton code and I just inputted what I needed to put down there. Pretty straightforward. Then I modeled it using new colors, white and red. And then boom, here was a model. So as you can see, very big difference. Look at all those arrows versus that just has one arrow. It's pretty big. And the numbers are different too. So here's the discussion. If I had modeled each of my tapes as a single point charge, then comparing the estimated value of the charge that I got when I used my experimental's data to produce a point charge model versus the value I got with my line charge. So there's a 2.1% difference, which is you get by calculating. I use a calculator to get that percentage, and the line charge has to have a greater charge than the point charge. As you can see how big all of the vectors were in the previous slide. Why did they differ, and what is most likely to be the real deal? I believe these estimates differ because one is a point charge and the other is uniformly distributed along the length of the tape. The value that's going to be closer to the real value is the value for the uniformly distributed model because it's more realistic, since the shape at the end of the day is shaped like a rod instead of a point charge. It's like a long rectangle. And some errors could have been calculation mistakes, the timing that I ripped out the tape and not seeing the number properly on the ruler while measuring. But other than that, it should be solid. Thank you.